video, we are going to look at covalent compounds. So the last time we had chemistry, we looked at the ionic bonding. So according to our syllabus today, we are going to describe the formation of covalent bonds. So the first thing that we are going to do is to define covalent compounds. So what comes into our mind whenever we hear the term covalent compounds? Okay, so we need to know that covalent compounds are substances or compounds formed when two or more non-atoms share electrons to bond together. Okay, so if we remember very well, last time we talked about ionic bonding, and we said ionic bonding involves losing and gaining of electrons. For covalent compounds, they involve sharing of electrons. Okay, so the question that we need to ask ourselves is, why do they share electrons? So they share electrons in order to achieve stable electron arrangements, okay, or to gain stability, okay. And we also need to remember that covalent compounds are also known as, or they are also called, molecular compounds. Covalent compounds are also called molecular compounds. Take note, on the outermost shell, okay, on the outermost shell electrons are shown, or let me put it in this way, on the electrons in the outermost shell, or on the electrons in the last shell are shown, okay. And these electrons in the last shells are the one that involves in the sharing of, in the process of sharing, so that covalent compounds can be formed, okay. So we have examples of ionic compounds here. Number one, we have water, H2O. So as we can see, hydrogen and oxygen, these are non-metals. We also have carbon dioxide, CO2. So carbon and oxygen, these two elements are non-metal. We also have methane, CH4. So carbon and hydrogen, these are non-metal. We also have ammonia, NH3. So we have seen that nitrogen and hydrogen, these are non-metal. So these four compounds are examples of covalent compounds, okay, examples of covalent compounds. We also need to remember that the number of outermost electrons shared determine the number of bonds. So the number of electrons in the outermost shell shared determine the number of bonds. So for example, if two electrons in the outermost shell have been shared, then it means that particular element has formed two bonds. So the number of outermost electron shared determine the number of bonds. Okay, so we are going to illustrate what we are talking about by looking at the formation of hydrogen molecule. Hydrogen molecule is an example of a covalent compound. Remember we said covalent compounds or covalent compounds are also called molecular compounds. So therefore, we have seen that hydrogen molecule is a covalent compound. So let us look at the formation of this compound. So we are going to start with the molecular formula. So since we are talking about the molecule, there are two atoms of hydrogen bonding together. Okay, so we have H2, we have H2. Let us come up with the electronic configuration. So the electronic configuration of hydrogen is 1. Okay, so only one atom is found in the outermost shell of the hydrogen. So we have seen that there is only one electron in the outermost shell. So let us draw. We are going to draw the electronic configuration. So we are going to say hydrogen plus hydrogen. We are going to get H2. H2. Okay. So let us draw. We have hydrogen here, one electron in the outermost shell according to the electronic configuration given. We also have this one, hydrogen, and one electron in the outermost shell. Okay, so these two will share. So for these two elements to be stable, they need to lose the one electron in the outermost shell. So instead of losing this one electron in the outermost shell, they will share the same electron in the outermost uh, shell so that they can gain a stable electron arrangement. So we know that the first shell, the first shell is supposed to accommodate two electrons. Then the second shell, 8 electrons, according to the formula that we used last time. So these two will share these two electrons. So the first one will share the electron with the second one. Then they will have two electrons in the outermost shell, or in the first shell, sorry, in the first shell. So as we can see, we have two shells. So these two elements, they have gained stability. Why are we saying they have gained stability? The first shell supposed to accommodate two electrons, and the first shell has finally accommodated two electrons. Okay, so we are also going to look at the formation of water. Formation of water. Okay, water molecule. So remember we said covalent compounds are also known as molecular compounds. So therefore, water molecule is a covalent compound. So the first thing that we are going to do is to come up with the molecular formula, H2O. Okay, let us come up with the electronic configuration of each element in this compound. We start with the hydrogen. Hydrogen, the electronic configuration is 1. Oxygen. Oxygen, the atomic number of oxygen is 8. So breaking down 8 into electronic configuration, we are going to have 2 to 6. Okay, so we have seen that hydrogen has one electron in the last shell, in the first and last shell. Then oxygen has 6 electrons in the last shell. So these are the numbers that we'll be dealing with as we'll be uh, uh, demonstrating the formation of water molecule. Okay, so the number of electrons in the outermost shell, in the last and in the first and last of hydrogen atom is 1, oxygen 6. Okay, we are going to come up with the chemical equation. So we are going to say hydrogen plus oxygen plus another hydrogen. Remember, there are two atoms of hydrogen here, is equal to H is equal to H2O. Okay, is equal to H2O. Now let us come up with the electronic structure. Okay, so we have hydrogen. We have hydrogen with the one electron in the outermost shell. We also have oxygen with the 6 electrons in the outermost shell, as illustrated here, plus the hydrogen with the one electron in the outermost shell. Okay, so if we remember very well, we said hydrogen needs to lose this one electron for it to gain stability. Okay, and this one also need to lose this one electron for it to gain stability. And we have oxygen here. So this is the outermost, this is the outermost shell. And this outermost shell is supposed to have 8 electrons. As we can see, it has 6 electrons in the outermost shell. So therefore, oxygen needs to gain 2 electrons in order for it to be stable. So instead of gaining those 2 electrons, oxygen is going to lose 2 out of these 6 electrons so that it can gain stability. So let us see the compound that will be formed. So we are going to start by drawing the oxygen. Oxygen is surrounded by hydrogen here, hydrogen here. Okay, so this hydrogen will will share one electron. This one also will share one electron. And this one will share one electron here. Okay, share one electron. So we have seen that instead of gaining 2 electrons in order for oxygen to be stable, it has shared 2 electrons out of 6 electrons in the outermost shell. And for hydrogen, instead of losing 1 electron so that hydrogen can be stable, it has shared only 1 electron in the first and last shell. So as we can see, after sharing these electrons, we can see that we have come up with 8 electrons here. 8 electrons. So therefore, this compound has gained stability. So the whole essence of sharing electrons is to gain stability. Okay, to gain stability. So we have seen that this compound is now stable. So the next example that we are going to look at, the formation of carbon dioxide molecule. So carbon dioxide molecule is also a covalent compound. So the first thing that we are going to look at, we are going to come up with a molecular formula. Okay, we are going to come up with molecular formula, which is the CO2. Okay, let us write each and every electronic configuration. Then, okay, the atomic number of carbon is 6. So breaking down 6 into our electronic configuration, we are going to come up with 2 to 4. Let us also break down 8. So breaking down 8, we are going to have 2 to 6. Okay, we are going to have 2 to 6. The next thing that we are going to do is to come up with the molecular formula. Okay, so we are going to say oxygen plus carbon plus oxygen is equal to carbon dioxide, CO2. Okay, is equal to CO2. Now let us come up with the equation showing electronic structures. So we have seen that oxygen has 6 electrons in the outermost shell. 6 electrons in the outermost shell. So we have 6 electrons here plus carbon. Okay, we have also seen that carbon has 4 electrons in the outermost shell. Okay, 4 electrons in the outermost shell. We have 4 electrons, 1, 2, 2, sorry, 2, okay, 3, 4. So we can see 4 electrons in the outermost shell of carbon atom plus another oxygen atom. Let us draw here. Oxygen atom, 1 electron. Okay, the second electron, third electron, fourth electron, fifth electron, sixth electron. So we can also see that even this one has 6 electrons in the outermost shell. Okay, so we have seen that carbon has 4 electrons in the outermost shell. So in order for carbon to be stable, it needs to gain 4 electrons. So instead of gaining 4 electrons, carbon is going to lose the same 4 electrons. It is going to share, the same 4 electrons. And we have also oxygen here with the 6 electrons in the outermost shell. So for oxygen atom to be stable, it needs to gain 2 electrons. So instead of gaining 2 electrons, it is going to lose 2 out of 6 electrons. Okay, 2 out of 6 electrons. So let us illustrate the molecular compound that will be formed here. So we have carbon surrounded by 2 atoms of oxygen. We have this one and we have this one. So remember, I am from saying carbon is supposed to gain 2 electrons in order for it to be stable. So instead of gaining 2 electrons, instead of gaining or losing 2 electrons, it is going to share the same 4 electrons. It will share 2 electrons with this oxygen. It will also share 2 electrons with this oxygen. Okay, and we can see that this oxygen has 6 electrons in the outermost shell. So instead of gaining 2 electrons so that it can become stable, it is going to share 2 out of 6 electrons in the outermost shell. Okay, so it will share 2. It will share 2. Even this one will share 2. Then the remaining 4 electrons will be located here. This one also, the remaining 4 electrons will be located here. So as we can see, even this compound has gained stability. Why are we saying it has gained stability? We can see 8 electrons in the outermost shell. So therefore, the whole essence of coming up with these ionic bondings is to gain stability. So we have seen that even this one has gained stability. Okay, it has gained stability, as we can see 80 electrons in the outermost shell, or 8 electrons shared in the outermost uh, shell. Okay, the last example that we are going to look at formation of ammonia. Okay, formation of ammonia. Ammonia is also a molecule. So the first thing that we are going to do is to come up with the molecular formula. We are going to come up with the molecular formula, which is the NH3. Okay, now let us come up with the electronic configuration. So we are going to start with the nitrogen. So the atomic number of nitrogen, according to our periodic table, is 5. Okay, so we have the electron configuration, which is 2 to 3, and the electron configuration of hydrogen is 1. So we can see that nitrogen has 3 electrons in the outermost shell. So it should be 5 electrons, not 3 electrons. Okay, so it should be 3. Yes, 3 electrons in the outermost shell. And the hydrogen has 1 electron in the outermost shell. So let us come up with the chemical equation. So we are going to say hydrogen plus hydrogen plus nitrogen plus hydrogen. We are going to form nitrogen. We are going to form ammonia molecule. Okay, we are going to form ammonia molecule. Let us come up with an equation showing electronic structures. So we are going to start with nitrogen. So nitrogen has uh, nitrogen has nitrogen plus hydrogen, nitrogen plus hydrogen, nitrogen plus hydrogen. Okay, nitrogen plus hydrogen. Nitrogen has um, 5 electrons in the outermost shell. Sorry, I made a mistake here. The atomic number of nitrogen is 7. So after coming up with the electronic configuration, we are going to have 5 here. So here we're supposed to have 5, not 3. Here we're supposed to have 5. Let me do this. Here we're supposed to have 5 like this. Here we're supposed to have 5. Okay. Here we're supposed to have 5. So nitrogen has 5 electrons in the outermost shell. Hydrogen, 1 electron in the outermost shell. Even this one electron in the outermost shell. So we have seen that for nitrogen to be stable, it needs to gain 3 electrons in order for it to gain stability. Okay. Then for hydrogen to be stable, it needs to lose 1 electron in the first and last electron. Okay. In the first and last shell, not electron, shell. So we are going to come up with the compound that will look like this. We have nitrogen surrounded by hydrogen, hydrogen, another hydrogen. Okay. So we have seen that in order for this one to be stable, it needs to have um, to have 3 more electrons. So instead of gaining 3 more electrons, it will lose 3 electrons out of 5 electrons. So it will share 1 electron with this hydrogen, 1 electron with this hydrogen, 1 electron with this hydrogen. Then this hydrogen will share, the remaining 2 electrons will be here. Okay, they will be located here. Then this hydrogen will share 1 electron with this one. Then this hydrogen will share 1 electron with this one. This hydrogen will share 1 electron with this one. Okay, so even this one, we have seen that it has 8 electrons in the outermost shell. So therefore, we have seen that it has gained stability. Okay, it has gained stability. Okay, so Now let us look at the properties of covalent compounds. So what are physical properties of covalent compounds? So we need to remember that covalent compounds are made of molecules. Covalent compounds are made of molecules. Okay, they have low melting and boiling points. They have low melting and boiling points because of forces of attraction which hold the molecules. They have low force of attraction because of the weak forces of attraction. So remember, when we were looking at the physical properties of ionic bonding, we said ionic compounds have high melting and boiling points due to strong force of attraction. But for covalent compounds, they have low melting and boiling points because they have weak force of attraction which hold the molecules. So for this reason, they have low melting and boiling point. The next physical property, they are insoluble in water but soluble in organic solvents like ethanol and petrol. So they are insoluble. In short, they cannot dissolve in water. They cannot dissolve in water. Okay. The next physical property, they do not conduct electricity, even in the molten state, in solid state or solution state, or because they are made up of molecules. So ionic compounds are not capable of conducting electricity because they are made up of molecules. They are made up of molecules. They are generally volatile. So covalent compounds are volatile. Okay, covalent compounds are volatile. So we are going to answer this question, which is coming from 2019 paper 2, to test our understanding. And this question is question A19. The question reads, the compound represented below is, we have this compound here, A, ethene, B, ethine, C, ethane, D, ethanol. Okay, A, ethene, B, ethine, C, ethane, D, ethanol. So as we can see, this one is capable of making bonds. So this carbon here has shared 2 electrons. This carbon has shared 4 electrons. It has shared 2 electrons to this carbon. It has also shared 1 electron to this hydrogen here. It has also shared 1 electron to this hydrogen here. This carbon also has shared 2 electrons to this carbon. It has also shared 1 electron to this hydrogen. It has also shared 1 electron to this hydrogen. Okay. So if we remember very well, we said the number of outermost electrons shared determine the number of bonds. So let us determine the number of bonds. So 1, 2, 3, 4. Okay. 1, 2, 3, 4. And here we have 2 bonds. 1, 2. So this one is capable of making 6 bonds. It's capable of making 6 bonds. So there is the first one. The first one is ethene. This one is ethene. The second one is this is ethine. The third one is ethane. The fourth one is ethano alcohol. Okay. Our correct answer, therefore, is this one. Our correct answer is this one. So ethene is the one that is capable of making 6 is the one that is capable of making 6 bonds. Okay. So therefore, our correct answer is A. Our correct answer is A. We shift to the next question. And this question is coming from 2013 past paper. And the question is question 25. Question 25 reads, which pair of elements form a compound by sharing electrons? A. Carbon and chlorine. B. Lithium and iodine. C. Neon and oxygen. D. Potassium and bromine. Okay. So if we remember very well, we said ionic compounds are compounds formed between or among non-metals. So lithium is a metal, potassium is a metal. Okay. And neon is a noble gas. Or it is coming from group 0 or group 8. This one is coming from group 0 or group 8 or group 18. And these are called noble gases. So the noble gases are stable. These are stable in nature, hence they cannot react with any element. Okay. So we are going to illustrate so that we can understand the question properly. So the only two non-metals that we have here is carbon and chlorine. Neon and oxygen are also non-metals, but this one here, this one has 8 electrons in the outermost shell. So therefore, it cannot react with any element. So our answer is A, carbon and chlorine. So carbon and chlorine are capable of forming the compound called tetrachloride. Okay. CCl4. CCl4. Let us come up with the electronic configuration of each element in this compound. Carbon C, we have 8, we have 6. 6, we come up with the electronic configuration. We come up with the electronic configuration. We are going to have 2 to 4. Okay. Then let us also deal with the chlorine. Chlorine, 7 electrons in the outermost shell. Number of electrons, 17. Electrons in the outermost shell are 7. So we are going to start by drawing carbon, and this carbon is surrounded by 4 chlorine. This one, this one, this one. Okay. So as we can see, this carbon is surrounded by 4 chlorines. And As we can see here, carbon has 4 electrons in the outermost shell. So instead of gaining 4 electrons for this to be stable, it is going to share the same 4 electrons so that it can gain stability. So this one here, this one will be shared here, this one will be shared here, this one will be shared here. Then for chlorine supposed to have 8 electrons in the outermost shell. So this supposed to gain 1 electron. So instead of gaining 1 electron, it is going to share 1 out of 7 electrons. This one also would do the same. This one would do the same. This one also do the same. So as we can see, we have successfully managed to come up with a stable electronic, a stable outermost shell. Stable outermost shell. So we have seen that this one will form lithium and iodine will form ionic compound. Potassium and bromine also form ionic compound. Okay. For carbon and chlorine will form covalent compounds by sharing electrons. Okay. So ionic compound is formed by gaining and losing of outermost electrons. Ionic compound is formed by gaining and losing of outermost electrons so that they can gain stability. We are also going to answer this question, which is coming from 2011 past paper, and the question is question 3. Element E, whose proton number is 7, combines with the hydrogen to form a gas. The diagram below shows the bonding in one molecule of this gas. Question 3a, identify element E. Identify element E. So here we have hydrogen. So according to our electronic configuration, or according to our timetable, an element with 5 electrons in the outermost shell, the dotted electrons, we have this one, we have this one, we have this one, we have this one, is nitrogen. So our answer here is nitrogen. Question B, what is the name of the gas? So the name of the gas is ammonia gas. So this is ammonia gas. Question C, write the chemical formula of the gas. So the chemical formula of the gas is NH3. Question D, what type of bonding holds the atoms? What type of bonding holds the atoms together in this compound? So the type of bonding is covalent bonding. Question E, state one physical property of the gas that is due to the type of bonding it has. So this is a covalent compound, and we said covalent compound do not conduct electricity because they are made up of what? Molecules. They are made up of molecules. The last part of this question, name another compound which has the same type of bonding. Name another compound which has the same type of bonding. So carbon dioxide also has covalent bonding, or the elements in the carbon dioxide are combined by sharing electrons, thereby forming covalent bonding. Okay, so we are done with this question. Let us move to the next question. This one is coming from 2010 and the question is question 26. When two atoms share electrons, they form dash A, ionic compound, B, a molecule, C, a lattice, D, an allotrope. Okay, so if we remember very well, we said covalent compounds are also called molecular compounds. So therefore, when two atoms share electrons, they'll form a molecule or molecular compound. Not an ionic compound, not a lattice, not an allotrope, but a molecule. So a molecule be formed out of two atoms that share electrons or that have shared electrons. Okay, so therefore our correct answer here is B, not A. Our correct answer is B. Our correct answer is B here. Okay. We move to the next question. Which is question. This question is coming from 2019 paper 2, and the question is question not paper 3, paper 2, and the question is question A6. Which of the following molecules has a triple bond? We have A, chlorine molecule, B, carbon dioxide, C, nitrogen molecule, D, oxygen molecule. Okay, so chlorine has, so I'm going to bring back this statement. So the number of outermost electron shared determine the number of bonds. So chlorine has 7 electrons in the outermost shell. So for chlorine to be stable, it requires to gain 1 electron. So instead of gaining that 1 electron, chlorine will lose one of the 7 electrons will share one of the 7 electrons in the outermost shell. So therefore, two chlorine atoms will form a single bond. Carbon dioxide will form double bond. Then oxygen will also form a single bond. For nitrogen, let us look at nitrogen. So nitrogen, we are going to come up with the electronic configuration. So the atomic number or electron number of nitrogen is 7, and the electronic configuration is 225. Let us come up with the electronic structure. We come up with electronic structure. So we have nitrogen. We also have nitrogen here. So it has 5 electrons in the outermost shell. 5 electrons in the outermost shell, and in order for it to be stable, it needs to gain 3 electrons. So instead of gaining 3 electrons, it is going to share 3 out of the 5 electrons. 3 out of the 5 electrons. And it will remain with 2 electrons in the outermost shell. So each nitrogen atom, so to say, will remain with 2 electrons in the outermost shell. So the first one has shared 3 electrons. Even the second one has shared 3 electrons. So therefore, we can see that stability has been acquired Stability has been acquired. Stability has been acquired. Yes, stability has been acquired. If we look at this one here, stability has been acquired. We have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Even here, 1, 2, 3, 4, 5, 6, 7, 8. So stability has been acquired. So we have seen that this one is capable of sharing 3 electrons, even this one 3 electrons. So therefore, a nitrogen molecule is the one that is capable of forming a triple bond. So therefore, our correct answer is nitrogen. Our correct answer is nitrogen. Okay. For oxygen here we should have two electrons, not one.